If you've ever had to make a daily planner, then you are intuitively aware of topological sort. It's not too difficult for a person to create a sequential order. For a machine, there has to be some way of evaluating an order of various tasks to go through. The idea of topological sort is tasks are organized as nodes on a DAG. These nodes are connected to one another with adjacency lists. The node that does not have another node pointing to it originally is your start node, as if nothing is before it, then by definition it is the first. You then save this node in a list of some kind while deleting it from the DAG. The algorithm will then move on to the next node with no edges pointing to it and repeat the process. This will form a sequence of nodes, from your original node to the last node. For an example of how topological sort is used, let's look at two cryptocurrencies and how topological sort can affect cryptocurrency traders. Bitcoin is a list of blocks, a block being a series of transactions at a given time represented as a hash. Each block also has a hash that connects to the most recently created block. Each block is placed on a chronological list, which is then given as a ledger to everyone on a P2P network. To verify if each block on a blockchain is correct, miners, a combination of hardware and software designed to identify hashes, are ran on the blockchain every time a new block is created. Miners are rewarded for mining by getting a small payment in bitcoins for every transaction that they mine. These rewards for the miners count as fees to people making transactions. These miners require great processing power, which can only really be obtained by corporations, and this can harm the integrity or security of a decentralized banking system. So how do we solve this? Some are asking now, why do we even need blocks, or the miners and fees that accompany that? IOTA, for example, uses a DAG rather than a list to function for transactions. Two Genesis nodes are created at creation, called sites, which each hold a hash that represents edges that connect to it directly and indirectly, as well as the transaction data of that site. As of that moment, they are unverified, as well as any other node created in the beginning. The edges that indirectly and directly connect to that site are called its weight. When a new transaction is made in IOTA, a node or a site is placed on a DAG, and this verifies any past two unverified nodes randomly, acting like a miner when a person makes a transaction. It also adds its weight of 1 to the newly verified nodes, and those newly verified nodes add their weight to even older nodes. This total weight can be formed via topological sort for every time a new node is added to older nodes. Currency traders also use topological sort in other ways. Some DLLs in computers can be formed using topological sort. Sending data over connection or data serialization also uses topological sort to sequentially form strings to send to receivers. This is also used to make orderings for cell evaluations on spreadsheets. Note that these applications don't just affect those in currency trading, but just about anyone with access to a computer. Although topological sort is a simple algorithm, it is perhaps one of the most necessary for automated processes in the information age, and this looks like it will be the case for quite some time to come.